Hello everyone. I'm Sudesh Kataria, the chairperson of MUJACM SIGBED student chapter. And on behalf of our student chapter, I would like to welcome you all to our premier offline event, Director's Talk. MUJACM SIGBED student chapter is India's first ACM SIGBED. There is a special interest group for embedded systems here at Manipal University, Jaipur. We believe in empowering students to discover, tinker, and create using the technologies of embedded systems and IoT. There have been countless times when we've noticed that embedded systems and IoT is the future and that it's not a restricted domain. Now, what do I mean by that? Let's say end-to-end solutions that are powered by embedded systems and IoT is something that involves the use of multiple domains of engineering, such as computer science, electronics, and mechanics. So to further discuss this, we will have a panel discussion today with our esteemed directors on the topic Embedded Systems and IoT, an interdisciplinary domain, a combination of computers, electronics, and mechanics. Before proceeding further, allow me to introduce the directors who will be our panelists for today. First off, we have Dr. Rajveer Singh Shekhawat, who is the Dean, Faculty of Engineering, Provost, and Director, School of Computing and Information Technology, Manipal University, Jaipur. Dr. Rajveer has over 34 years of experience in applied and industrial research and development. He is also the project mentor of the Computer Society of India from the year 2013. His education being from Birla Institute of Technology, Pilani, with a PhD in soft computing and MSc in electronic sciences and physics. A few of his projects include architecting IoT applications, ultrasonics for flow measurement, system-level modeling for designing embedded systems, smart metering, smart grids, computer networks, and distributed computing, GIS, and spatial decision support systems. Now, with a publication in COMSOL, Indian Annual Conference 2012 on the topic of innovating new products using multi-physics modeling, and Sir has also served as the chairman of Jaipur ACM student chapter. He is also the faculty sponsor of MUJACM SIGBED student chapter. Next up, we have Dr. Jamal Akhtar, who is the director of School of Electrical, Electronics and Communication Engineering, Manipal University, Jaipur. He started his career with BEL Ghaziabad as a Plan B, from where he moved on to CSIR CD Pilani in 1980 on CSIR Fellowship, and later in 1983 was appointed as scientist for R&D in semiconductor devices and technology. He was officiated as Director CSIR CD Pilani intermittently. His research capabilities include technology for X and W band silicon-based impacts and barrettes, numerical techniques for device simulation, design, and fabrication of microstrip detectors and MEVIM assisted techniques for nanostructure formation in single crystalline silicon. He holds many patents to his credit and more than 200 papers in journals and conferences, along with being a senior member of IEEE USA and member of International Solar Energy Society Freiburg, Germany. He's an awardee of CSIR New Idea Fund Project, Bharat Shikshan Ratan, by Global Society for Health and Education Growth, New Delhi. Moving on, Dr. Shiv Prasad Etsi, Director of School of Automobile, Mechanical and Mechatronics. Professor Shiv Prasad Etsi has a vast teaching and research experience of more than 26 years in MIT Mahe Manipal. Previously, he worked as a professor in the Department of Humanities and Management, along with teaching fundamentals of management courses to undergraduate students. He joined Mechanical Engineering Department, MIT Manipal, as a faculty in 1992. He is also the coordinator for an MOU signed between Texas Tech University, US, and Mahe Manipal regarding the research project Ethical Engineers. He played a major role in signing an MOU between Mahe and the Agricultural University, Shimoga. He has published more than 25 papers in reputed international and national journals like Acta Mechanica Malaysia, International Journal of Civil Engineering and Technology, and has presented several papers in a plethora of international and national conferences. So without further ado, let's move on to the exciting questions we have ready for our distinguished panelists today. Starting off, this is a question to all our panelists today, and we'd love to get your perspective on that. And that is, what is embedded systems and IoT to you? Like, how can we categorize embedded systems and IoT in the fields of computer science, electronics, and mechanics?
Okay, so I request Prof. Jamil if you wish to say, or should I start?
Okay. Thank you. See, when we talk of computer science or computers, so basically computer is an electronic system. So with time, actually, computer has taken a place where people have forgot the role of the electronics as such. So these are the subsections of the main electronics, where electronic is a subset of technology. This is first thing, but technology itself is not the electronics. The components, the circuits, and how to make the circuits interconnected to make the whole thing smart, and so on. So, when we think about these embedded systems and the IoT, so you will find everywhere where electronics lab is there, then these things will also be there. For example, say Repilani, we are having only these divisions there. One is technology division, others are electronic systems division. So without IoT and without embedded systems, now we cannot actually come to the market. Now, coming to your question, dedicated question, electronics is there, but electronics has gone further through their siblings, I will say, IoT and the embedded systems, which are actually which are components to communicate with the outside world, to market the electronics. Suppose I make a device in the lab, but it cannot be actually marketable until unless it is connected. It is. I will say that it should be IoT enabled. I mean, it should be able to communicate with other devices also, and the whole design and the system. Then it has a meaning, and this is very, very important. And if we don't know the technology, the device we have here, then certainly we cannot develop the unique design of IoT and the embedded system. So we have, if we want to take a lead in this, then we have to understand the latest components, latest technology, and what is the requirement where actually it can communicate. So this is all actually interconnected, and that's why it is more interdisciplinary now. We cannot say that, for example, in device design, software is required. Similarly, in the system design, software is required. But it has become so involved that perhaps for one person it may be difficult to have all the things. So that's why a team is required. And perhaps we will say something more in the time to come, that why our technology is in the lab and why not in the market.
Correct. So definitely agreed that we should empower more people to make marketable solutions, marketable end-to-end solutions. So do you all have any other views?
So I request my colleague Prasadji to further comment on this.
Yeah. See, whenever there is even if you take a small component like a computer, it has a hard disk in which the hard disk has to retrieve. There is a linkage mechanism. The link has to go and search for which sector and which the path that it has to travel. So the moment whenever there is a drive, there is a mechanical device. Any component if you take like that, the elements of mechanical engineering comes in the picture. For example, the force analysis you have to do, the linkage mechanism that you have to study, the thermodynamic aspects of it has to be there. As you know that in computer also there is a source of sink and enthalpy has been studied in the process. So the entire process of whatever the present Internet of Things, that is IoT, is going on, should go, if you ask me, it should get embedded with the mechanics of the mechanical components that is there. Without that, if you do it and finally it may fail. You may design it in the simulation, everything like that, but when it comes to the practical aspect, it may fail. This is my view. So embedding the practical aspects and the real world is very important. So wherever there is a component of a screw has to be fitted, whether it is a star screw or the bolt that is fitted, it needs a mechanical thing. So mechanical also has an relevance to the electronics and other things, the software also. So now there is no bifurcations, there is no demarcation. Everyone is integrated like that. Now we have to, our students also have to learn many things on the process level. This is my view on this particular case.
Yes, sir.
Okay. So having listened to their perspectives on embedded in IoT, I would give my views. Of course, I would like to inform that my whole career has gone through this embedded systems technology. And though I started with physics, as you have yourself read out, and there also we work with the systems, all sort of systems for measurements, optical or laser, whatever. And then coming to the electronics field, and by profession, day one, I have been involved in the computer systems. So we have seen those 8 bits, 16 bits, whole generation I have seen and worked with it. But always I have seen the sense that whether it's a computer, it is a mechanical system, they have to all work together. So I am a very big prominent promoter, also the supporter of systems theory or systems application, because we as an engineer, if you think, we are problem solvers, and almost any problem you take, it does involve all the domains of the engineering. I mean, it is not just a computers, or it's not just programming, or it's not just the mechanical. So I just give you an example, take the mobiles, today's mobiles, smart mobiles. So if you really see, there is a whole of the electronics is there, mechanical is all the concept, mechanical components are there, and programs are there which are actually driving the whole of this thing. So, but because of the technology evolution, all those systems that we have witnessed in 70s, 80s, where big rooms were there, a small controller. If you think of a plant controllers, for example, think of take a simple process of crystallization or sugar refining. So we take sugar cane juice and then we refine it. So think of a process. And if you have a control system, it's a big computer system, taking whole space on the room or the plant. So plant is full of all those big equipments with the racks, and there are inside, there are 8, 16-bit computers. But I would say they were the earlier generation of IoT. Today, when you talk of IoT, it's not just the microcomputer, or it is just not the program, or it's not that the sensors. I mean, really, when you have to put together, it's a system. And when you develop a system, you need all the domain knowledge, whether mechanical, thermal, everything. So, we, of course, there was time when we were working only on designing the embedded part. Embedded part means we normally say that it is a computer which is actually embedded. So, when we talk of that, now today, earlier, there were days when we say everything has been electronized, electronics, everywhere electronics. So I remember those days when everything has become electronics, So you see any machine, electronics is there. And before that, I mean, you people may be not even able to visualize that there were days when, controller was there, but it's a big capacitors, big resistances. All that have converged into very small. So in fact, you don't need so many people to develop those things, because they are ready. They are developed in semiconductor fabs, and there are designers who develop and give you. So life has become so easy that with the IoT now, the whole computer system, all your 8 cores or 10 cores are there on a small chip. You have got all the sensors which are mostly in the integrated form. So development has taken a different view now. It's not that olden days where that you need screwdrivers and everything. So, I mean, IoT really is, I would say, is a miniaturization of whole systems development. And so earlier also the concepts remain same. You need all the domain experts to really have an effective solution using IoT. So I need not go through whole of my experience of how embedded, what we did and all. But in nutshell, I would say that this is an evolution of systems development, and IoT is just one stage, I would say. Tomorrow you will see that you will not see anything that this is IoT. You will not see, it is everywhere. So like we say today, computing is ubiquitous. No, it is everywhere. You don't know, you say anywhere, somewhere or there it is hidden.
We could never know.
So
like these
IoT
sofas could be connected to the internet. And
So IoT is going to get vanished. You will not see a device per se, but this will be whole embedded and you won't see. So they will be all embedded electronics, embedded computers, embedded mechanics. Everything will be hidden. And one will not really see, is there something controlling this? So like we say, that's the other extreme, and I believe in this. There is some superpower which runs everything. And that will be the superpower running everything. So this is my small thinking on this whole view. Of course, we can examine more details of this, but this is the top level thinking I have.
Actually, his career started from embedded systems and the computer's desktop systems started.
Yes,
So
yes.
you are there in series of
Even-
very beginnings of the
Even in Hindustan Aeronautics, when we were working for radars. So for radars, the signal processing those days, I think the most complex signal processing was used in radars that time. And so we needed really a very good computing power. And those were the days I remember in Hyderabad. Used to have these 4-bit computers, no CPUs, 4-bit CPUs. So there is a small ALU for 4-bit. There is a data path, there is a bus, and you need a 16-bit computer, but you don't have. So you put these bricks of 4 bits each, visualize a 16-bit system, write the assembler for that, write the machine code for that, and develop software.
I guess now things have become.
You can't
very
think
simple.
of those things. It was such an enjoyable thing. We used to always be so happy. But today things are different. But there is a lot to innovate. Now is in a different perspective.
We can definitely not compare our generations because you all had a whole different aspect of the embedded systems and IoT. We have a totally different aspect of it.
But you have to look into, given this, what is the innovation I should bring in? That should be always, in a problem solving, your unique idea is the value that you deliver.
So the next question is something that's pretty specific to SEIT in general. That is the implementation of IoT. It relies heavily on monitoring the real-time data. So do you think that the growing need of data collection will face a bottleneck due to the existing standard of communication networks?
Okay, so as I told this, presently I am very much fascinated by the IoT and the best way to make use of this technology. And obviously, the generation of data is the one main part of this whole system development. So the way it has to be handled is, as rightly said, if you look at the data being generated, so there are maybe for a simple application, like even for our campus, if you think there are about 600 to 800 cameras. Now I would say they are nothing but the IoT, They are generating video, continuously. So you can imagine how much data is being generated. Now what happens if you think of, and that is what everybody is doing these days. I want to just upload to Amazon, I want to upload to Azure, okay, I want to upload to say IBM Bluemix. So that's not the right approach actually, because you can't handle that big data, and our whole networks are actually loaded with this data, and you don't get bandwidth for other applications. So the way things are happening now, everybody is looking at how we do everything at edge. That means right at the IoT device, that is the small computer.
A localized
maybe,
approach to it.
Yeah, or maybe the what we call as the next level, I forget the name. So cloud, don't cloud, something else.
Edge computing.
No, fog. Sorry. The next level is a fog. So where you have got all your equipment of routers and so that is the next level of computing. So if the application requires a lot of processing, then you move that processing at the fog level. And only when you have got some metadata or the basic analyzed stuff, then that should go to the cloud. So we should not put everything, don't dump everything on cloud, process the whole thing at the edge, and then that is refined data only you can upload. So the basic raw data is processed right at the edge. So whole of your concern about the data, so much data getting generated is handled. The only thing is now you can imagine the challenge is to move all those machine intelligence or whatever your big data analytics, everything algorithm you got to move to edge. So the simpler versions, obviously, the big data analytics that you do on cloud, the amount of data that the algorithm handles is huge. But as you go down, the data handling you require is less. So you can do still with lighter weight of the machine learning, lighter weight of AI, whether it's a vision processing, you have much less data to manage. So this is the way things are evolving. So today we are moving more and more towards edge, and that also has got a lot of benefits in terms of the response. So when you are processing the data right at the location, your real-time response is very fast. So automatically the problem is solved, because today we are concerned whenever there is a health problem, for example. So for the patient, you upload whole data in cloud and the cloud will process and respond back. That you lose a whole lot of time, and that is meaningless. By the time you don't know what has happened to the patient.
I couldn't agree more, sir.
Yeah.
We have a lot of support in terms of libraries. Like first, machine learning used to take place in the cloud. We had a
Yeah.
lot of ways to approach it. But now we have like stuff like tiny ML. So everything's happening at the edge, at the device itself.
Yeah.
Smaller versions of them are running. So we're able to get even low power applications that way. So the next question is specific to SEEC. So in recent years, there has been a lot of buzz around soft electronics, right? Particularly on the applications that range from biomedical, energy harvesting, electronic skin displays, and much more. So can you tell us more about soft electronics, on its future, its feasibility, and its career opportunities?
Tremendous applications. As I mentioned earlier, without electronics components, actually you cannot further progress in that more sophisticated applications. And the areas actually where coming up now, the flexible electronics, for example, you might have heard that electronics is changing its face from the rigid electronics to the flexible electronics, and that's why organic semiconductor or organic electronics coming up. And when we talk about the organic electronics, then it is more compatible with our biological system, and it has direct relevance with our healthcare applications. And here again, the advantage is the very low power and real time monitoring of the internal things which are going on, and this is coming up actually. For example, through microfluidics, the flow of the fluids being controlled, and if there is something else in the fluid, then how the flow mechanism is changed, so critically monitored, and this kind of technology actually is developed, and now it has to be converted into IoT enabled. So as I mentioned, so when we talk about the flexible electronics, the main work of flexible electronics will be appreciated when it is IoT enabled.
Yes, so currently all applications are, like they might be connected through Bluetooth. So flexible PCBs are something that is very trending.
Even you can wear it.
There are a lot of consumer electronics that are being made around that, and also nowadays in biomedical applications, like for diabetic patients, they used to have rigid PCBs out here that you could prick inside, and you would get real-time monitoring through Bluetooth. So now with flexible PCBs, it's becoming even more comfortable for the patient to monitor the data. So definitely there have been a lot of improvements in
There
that
are a
field.
lot of actually scope of electronics, I would say.
Yes, sir.
And accordingly, then embedded system and IoT actually will have the progress, further progress, I would say.
Agreed, sir. So the next question is specific to Sam. Embedded systems and IoT is used in a lot of sectors, like you discussed, and virtually IoT can be implemented everywhere. So we've already seen, that embedded systems and IoT is what the whole fourth industrial revolution is all about. So, what industries do you think can benefit us the most with the use of embedded systems and IoT in the next 10 years?
See, the present scenario is such that many industries are in a confusion state or in a transition phase. So whether to go for this matured technology industry, IoT and others. So they have their own reservation whether to follow this up. But some industries are already doing it. Now the entire gamut of manufacturing industries is changing from what you call removal process to additive process. The removal of waste and scraps have been outdated. Now we have to optimize because the resources is scarce. So most of the manufacturing companies are started that okay 3D printing, we have to go for metal printings. Now all those things have started in the process. So the manufacturing industries, a whole lot of changes have come in place. That automobile industry is also coming up. So the people who are core, they thought that the structural strength cannot be obtained. Now they have started giving that okay there is a strength can be obtained. So the belief in that new technologies that is there is causing some little hindrance. Once if they believe that yes this can be done, this is the one which will run for a longer period. Definitely all type of industries will get benefited. Starting from the simple gear to the any frame structure to the drivers, many things that are there. So all segments are to change their pattern of the in a phase wise they have to go for it. It may not be done in one this. Somewhere they need this in case the power failure and the IoTs all those things. If there is a major power failure, how it has to be compensated with the unconventional method like that. So the biggest challenge is most of the manufacturing industries have the highest labor forces. That is also another concern is here, isn't it? The moment that the people are to be replaced with the IoT and robotics and automation that is here, what are the challenges that are there for the manufacturing industries? Of course, quality is ensured with the advanced technologies that are there. Okay, you do not have to have the errors that are there. So when we talk of Six Sigma principles, there is a one defect in million parts like that. So the companies have started doing that process, and definitely they will be getting benefited with this IoT and embedded systems.
Yes, so for example, we have artisans, in archaic ages, they used to get, let's say, a block of wood and then they used to carve out stuff from that. But now we can do the same thing through additive methods. We can, just 3D print something like that. So a lot of people are, getting used to it. I guess one factor that is very important is that right now it's out of the reach of a lot of people because, the technology is not widely available, or if it's available, it's very expensive. So those are some issues that we
one of our MIT Password student has come out with a low-cost 3D printing by Vijay Varla, working in Fractalworks like that. So he conducted some workshops for our students also that how to start from scratch. What is design engineering? How you can start your work? They are giving many products to various industries also, telling that 3D is not an outdated one. Okay, so still it is they are getting mature like that. Very good.
So I will just add to Dr. Siv Prasad's comments. So manufacturing, of course, is likely to get benefited from these IoT technologies in a very significant way. Of course, embedded has already played a very significant role and it is still playing. But I think IoT will revolutionize the whole thing. The one thing, some obstacles which I think over the time they will get resolved is offerings, or rather I would say more of a standardization of IoT. So the protocols, the interfaces, they need to be the GUI, they need to be standardized. So that what happens, the same thing we actually faced in the distributed control systems era. There are so many people who are making their own systems and selling. So now if you got stuck with Hitachi, you can't use Toshiba systems. And Toshiba offers you certain things very economical, but because you tied up with Hitachi, so you got to use all their system, whether costly or not costly. So it led to
an ecosystem.
Yes, so it led to standardization in the domain of control and plant automation. And after that, everybody was forced to align with those standards, and you could put anybody's controller, anybody's display system, anybody's bus system in a same system. So IoT needs to have that sort of standardization now. And there are efforts, but I think it will take time. Industry 4 is one consortium which actually are trying to evolve that concept. So that's one aspect, that interoperable parts from different suppliers of IoT components, they must be compatible, and that can be only happen if we have got some standards in place. The other thing, probably people are afraid, is the data piracy or hacking, because once you put your whole of your plant on the net, because IoT does that. So any controller you put on network, and on that finally is on internet. So anybody can actually have access to its data. Or for example, in fact, more serious is the whole plant. So that is something people are still wary of, and we got to evolve very foolproof systems of data privacy. And unless that happens, probably people will go with a lot of trading very cautiously on this path.
Indeed, sir. Coming back to SCIT, there are many companies that collect a lot of user data every day, and we recently just discussed about some data privacy concerns and cybersecurity. So even though many of them claim that they can keep their users' data encrypted, there are still trust issues between the users and the company. So considering that IoT relies so heavily on data collection, what can be a possible solution to bridge a gap between the companies and the consumers?
Okay, so of course, this is a very central question in terms of the proliferation of IoT technologies. I don't think we see a solution in the nearby time frame, because there are many systems or IoT applications where you find a human being involved, and wherever human beings are involved, I think making them fully reliable, because they are human beings after all, and that is their trade. They cannot be 100% predicted, they cannot be 100% relied. So there are always the thoughts that govern their behavior. So they have got their own biases, premonitions. So that is going to be a very difficult part. Unless you remove the human element from the whole of the application of this IoT, then only you can talk something of the full reliability or full trust in the whole system. And till that time, I think even you can say in our connectivity to the whole cyberspace, I see this is the biggest problem. In spite of you doing a lot of preaching, a lot of guidance to the people, they still commit the mistakes in terms of their accounts getting hacked or money getting siphoned off because they clicked an link. And that, if they are involved in any IoT application, and that is likely to happen, because there will be many applications where you can't avoid that human being being in the loop somewhere. And everywhere that component enabling full trust, making the whole IoT application foolproof, in my opinion, going to be tough. So people are trying to evolve some trust management models. A lot of work is being done. And hopefully to great extent, this will be handled, but 100% foolproof, I still feel would never happen. So probably we have to think of some different ways of handling this data privacy, the encryption of data.
Agreed, sir.
Because in whatever complex traditional mathematics-based encryption you use, you are talking of now quantum computers. So we got to evolve, because you take 254-bit complex encryption, a flick of a second, the quantum computers, breaks it. So what is it that we got to encrypt with? So that's another thought people are working on, what is called the PQC, post-quantum cryptography, which actually will be not prone to break by human quantum computers. So those are the things people are digging into, and hopefully future IoT applications will become more secure, but of course not 100% secure.
So next up, back coming to SEC, we have a question for you. So nowadays everything can be connected to the internet. Even small battery operated devices are connected to the net. Right? Traditional cellular options such as 2G, 3G, or even higher category 4G modems that we have, they consume a lot of power. And they don't fit well with applications where only a small amount of data is transmitted. So cellular IoT was, of course, designed to meet the requirements of such low power and long range applications. So can you please tell us more about these low power devices, cellular IoT in general, and its potential in Indian IoT startups?
Yeah, actually, in the energy sector, there is a lot of research on, and the products are also there, that energy generating devices at very high rate and the energy capacity also to a larger value, so that it can sustain even the electric vehicles requirement, which is the biggest one, I will say, in this area. So now here in this case, the new materials which are having uh, new generation of energy generating devices in the form of the solid state batteries, and the solid state is the new one, and uh, even the lithium ion batteries people are working on it, and but they have their old experience in making the batteries, and those actually companies, they have put their effort in making the competitive batteries which may actually take this kind of requirement of the new generation of electronics or devices. So it is a very big area, and new batteries are coming up. Even the power, wireless transfer of power.
Yes, sir.
So that is also a way that how we can transfer the electric power wireless.
People are using Tesla coils also for that
Yes,
in some
yes, yes.
places.
So, so a lot of work actually already done in this area, and energy generation through the heat, thermodynamics, and through vibrations, and even from the sound also, and all together connected, and then actually remotely controlled. These are actually possible and already actually
People are working on it.
implemented
Yes, sir.
in many systems. So in developments, they have given a contract to Quebec, Hydro-Quebec. Hydro-Quebec is in Canada. They are the masters in making the batteries, and particularly packaging of the batteries. So this Mercedes-Benz actually, they have given the contract, full contract of their electric vehicles to this Hydro Quebec. So this, but actually, unfortunately, when we compare that our technology, where we are, the question comes that how, and as I see that how our students actually, where actually they should put their efforts. So I give one example that I have interaction with local industries. Local means Indian industries. And whenever they talk about the BAM sensors and other sensors, so they are not interested in the sensor itself because it is available in the market. They are interested that the electronic part, which is in between the sensor and the system, and system is application oriented. And this is the major problem that they are not getting this response from the people actually, or the technical persons. And another thing is, nobody in the outside world actually ready to solve this problem because this depends upon the application oriented. So, what is your application? Where to use it? What are the conditions of the operation?
Based on that, someone should be
You have to
designing.
decide.
Yes,
So
sir.
it will be very, highly costly for them if they take it. So this is the major problem, and this also involves embedded systems in IoT because that readout electronics, this enhances all those things together. So this is a big demand, and I think placement should be there.
Yes, sir. And in fact, a lot of people are shifting to the electric vehicle concept. So a lot of Indian startups, let it be Ola Electric, let it be Ather Energy, they are working towards making their own batteries within India. So even for the manufacturing sector, for the electronic sector,
Yes.
it's going to take a huge boost.
Batteries.
No, I mean, see, there are many things available, but there are some unique problems that are specific to India. And that is where actually we have to look. and our whole young engineers must take to those unique problems of India. So batteries are available, you can import batteries, but how really make use of this in most efficient manner for given application? All those derating, designing battery, how much power I must draw, at what rate I must draw the power. These are all the application specific. So we got to look at those unique problems that actually face, as Dr. Jamil Akhtar has rightly pointed out, that there are application specific problems, and India has got applications which are quite different from the other countries, which are developed countries, I would say. So I think for us, the onus is on to look at our own problems and solve them. And each of these problem solutions require very innovative thinking. It's not going to be just that you read something from there and solve the problem.
So, lastly, we have a couple of questions that are common to all branches that we'd like all of you to answer. Since there are a lot of giants that are investing in IoT, the competition is quite high for everyone. Do you think that it's a good time for students to aspire to have their own startups in IoT?
Well, I think I take the prerogative to talk first. Okay. So, if you look at the, basically, when we talk of IoT, so suppose some startup has to be there. What is it that they should provide? What is it offering that they should have? And in my opinion, it is the basic hardware, and of course, software is all dependent because we don't make microchips. So obviously, anybody makes chips, so he gives the compatible kernel, it gives a compatible embedded OS. And okay, so that is not much in our hands. So, but for startup, what is important is that you try to give you the required bundle to solve a particular problem. Like today, you can just go on a DF robot site, or there are many others. I want to have a health problem solved. So he give you, but these are all primitive. They are only for prototyping. They are not for solutioning. See, there is another misconception I want to remove from everybody's mind. Today, I take a prototype board, put some sensors, solve say temperature monitoring and weather monitoring and all those things. But that's not end of it. That is a 10%. You demonstrated a concept and so that it works. But when you productize that, put that whole damn thing into product, there is a 90% work still left out. And that will require a whole lot of toiling and perspiration. It's not that easy. So, what I think the startups should do, that they should come out with all such offerings which will take away all that 90% of toiling, and I can easily deploy that into my real problem. If that anybody does, like for example, I give you an example, Raspberry Pi. Everybody, B or C, whatever one uses, demonstrates a thing. But when it comes to a product, I have to sell it at damn low cost. Raspberry Pi, if I make a solution, I can't sell it. So I have to go for what is called Raspberry Pi Zero or something. There is a small thing which is bare minimum you need, and you add whatever is essential for the application and build on that. Then you can think of a real appropriate costing. So any startup thinks about that. I think there is plenty of requirement, I can tell you. Even in health sector, if you think, there will be n number of systems and all different, with different sensors, different components, different application software. They will be needed. So startups, what they can say, here is an application bundle. I can provide them the consultancy for the application software. And that is a tremendous scope for such startups. And we need thousands and thousands of such startups because there is a lot to be automated, lot to be, put in as a solution. So I think this is one approach a startup can take up.
Of course, so that's a very good point. To make a low-cost end-to-end solution, you need the bare minimum, and consultancy for that will really help startups. So when it comes to the current startup industry, with the semiconductor shortage, do you think it's a good time to go into the startup industry, especially in the field of embedded systems?
Actually, in semiconductors, because semiconductor needs a huge investment. to make actually some strategic areas, some strategic devices which are not easily available to our, for example, BRC, to ISRO, or so they may actually sanction the projects because not readily available to them. But the electronic itself actually, for the existing electronic active and passive devices available in the market, I think this itself is a good actually activity. And for example, Maxim chip,
Maxim Industries. Yeah.
we were working in polysilicon piezoelectric pressure sensor, I think before 2000. And there was no chip, nothing. Nobody knew about that what should be the chip because nobody was using MEMS sensors. Now actually in series, maybe after 2010, I saw that there was a advertisement from Maxim, and they developed a chip, in IC, and the name was IC for polysilicon piezoelectric pressure sensor. Dedicated IC. And now they are the leader. So the thing is that they knew that this is in the demand. And now you can directly connect the pressure sensor. Your pressure sensor now is a sellable device.
Now you have a lot of MEMS sensors out there that are produced by so many
But not all
companies.
MEMS sensor. Again, this is the application specific.
Yes, sir.
So, for example, you are having the gas sensor. So, a startup in developing the relevant electronics, which are deployable. So, you can deploy it with the sensor. That is also a requirement. That it should be connected and it should work with that. Because sometimes you can make a pressure sensor, for example, MEMS pressure sensor, maybe for thousands of this bar, or maybe 100 bar. It depends on the packaging, because the mechanical part is very, very important actually. Without that technique, you cannot make a device.
So again, we see that it's IoT and embedded systems is again a very interdisciplinary domain.
Very interesting.
So to conclude this session, we have a question for all the directors here. And that is, what advice would you give to students who are just starting to explore the domains of embedded systems and IoT? And for freshers especially, what does MUJ have to offer when we talk about the hardware and, of course, software on hardware culture on campus?
Okay, you can take over? Okay. So, as I think right in my first answer of the question you asked, I said today is the time for system engineers. In fact, there are a lot of deliberations on the question, what should be taught? Should we have BTECs in mechanical, BTECs in electronics, or should we have a BTEC in only engineering? So these are some very mundane discussions, and we still don't know whether we are on the right track, that offering BTEC in mechanical, BTEC in computers, and now further specialization of BTEC in AI, okay, BTEC in e-vehicles. So these are things only time will tell whether we were right or wrong. But when it comes to being a real engineer, it doesn't matter whether you are mechanical, you are electronics. What you have to understand is that you got to solve a problem, and the problem can be only solved when you have got the knowledge, at least some awareness. So you are an expert of programming, you know how well to design an algorithm, but just that is not enough. The view that we should have for any engineering student, it doesn't matter what branch. So you should sharpen the skills in your domain, but be aware about what are those interfaces. How do I interface when I solve a problem with a mechanical aspect for a computer engineer? Or for electronics engineer, you should know how my microcomputer or the sensors that electronics needs to talk to the microcomputer, what driver software I must develop. So this awareness has to be there, because otherwise you can't develop a operating system. And I have seen, I worked in industry also, and I know the biggest difficulty in system development is developing a very good interface between different domains. because that's really bottleneck. And unless you follow some of the uh, what you call very automated methods of interface designing, you can't arrive at optimal interfaces. So of course that will come later, but first you should learn what are the shortcomings. So if I know, I should know what is the shortcoming of sensor. Ideally I can think, say, every microsecond I want a reading for my control algorithm to work. But can you get that sensor value out in every microsecond? The sensor poor fellow says, I can give you a reading only in 1 second.
You
But
need to know the
I,
constraints.
being as a computer engineer, I don't know what is the sensor, how it works. So fine, there is an expert, but at least while working on a first level of design, I must be aware. I can't simply expect anything from the system. Same way is mechanical. Suppose there is a hard disk drive you want to develop. You should know what is the limitation of the motor that I will use. So today I say I want a 50,000 RPM motor drive to make it compatible with latest microprocessors. Can't think of it. 7200 RPM is the best today we get. The moment you move on, there are problems. And I can't simply say that, okay, I don't know this, I designed a 10,000 RPM. So this is the scenario today. You be expert in your domain, but for solving problems, you got to be a team. And the team member also should know, for example, mechanical guy also must know what is this hardware, what is this limitation, what is the software can do, so that when they talk to each other, they understand well and develop a system that really will actually be acceptable in the market.
So we
That's fine.
need to know the constraints, the computing constraints, the mechanical constraints, the
Yes.
electronics constraints, and then only we can make a
That's how
marketable
the
end-to-end
team works.
solution. Yes, sir. So what initiatives can we have from MUJ's side to boost this culture on campus?
Inter-school activity.
So first thing you are already doing.
So,
SEM and SIGBED is the one sort of sprint chapter. I think you have got all that possibilities to collaborate all the branches together. You can form project-specific teams. So I would request you that look at your own lives, see where are the systems required, develop prototypes of them. So you can build teams. So this team is going to look at, say, for example, battery charging. So don't worry, battery charging systems are there available in the market. Korea makes or Taiwan makes, they have got very good, very low cost chips. Don't bother. Look at the concept and see how you can improve upon them. Tomorrow your design idea Taiwan guys can take. So I would request you to make application specific teams, draw team members from every branch wherever you require, and let them work on state of art. Today, web is a knowledge ocean. So you can get almost all information, what is the state of art. So this is another thing actually I have been feeling always that people should know about. Whenever you work on a small problem, please know what is the state of art. If you so I made a drone, so what? Everybody is making a drone, and maybe 10 years back people have made a drone. What difference did you make? What difference did you make? That is what. And that you can only do if you know what is the latest drone technology and what are the challenges in that and how I should think about that, how to address that problem. That is what I expect from you guys. When you build teams, the teams must get those challenges real clear. So let's solve our own problems. Do not get a problem from the net or websites. There are plenty of problems, and this is what I've been telling from day one since I came to academics. And you guys should look at our own problems, but solve the problem in the best way, better way than what people have done. And then I can tell you there will be 1,000 patents coming out from SEM SIGBED.
So there are two key takeaways that I take from this talk. The first is, of course, look around you. There are loads of problems that we can solve. So we should ideate based on them. And the second is, what difference can you make? So that is something that I urge all entrepreneurs out there, all budding engineers out there to consider when you're thinking of working on a project. Because what difference you make to this world is
Yes.
what's going to make you, what's the differentiating factor for you. So I'd like to thank all the directors today who took time out and come to give us such an amazing talk. And I'm sure the audience really loved this talk and will engage and come and meet here and ask her lots of questions about embedded systems and IoT. So I
Sure.
guess the main aim of the talk that we had to prove that how embedded systems and IoT is an interdisciplinary domain was successfully done. So thank you, directors, once again for coming out and giving your time.
Thank you, Siddesh. I think it was a good session. We enjoyed because we also have been asked to actually look at some challenging issues that you really posed to us. So some of them were really very thought-provoking, and I hope that we try to satisfy your curiosity. And we are still available in future. So whenever you feel that there is a need, and we can provide our inputs in terms of our experience, whatever knowledge we gathered on during our working lives. So we'll be always keen to share with you and provide our inputs, guidance whenever you need. I would only wish that there should be plenty of teams. That is what I wish. And there will be plenty of patents and ideas will come out. We university supports them like anything. So please do that, and I think we should fly, very strongly with our MEG colors. Okay, so that is my wish.
Thank you, sir.
Okay.